Okay, this question comes from Lucas asking what the Laplace transform is for three different functions. So we have f of t equals 1, f of t equals e to the t, and f of t equals t. And the definition of the Laplace transform is what he gave in the question. So it's the integral from 0 to infinity of the function in question times e to the minus s times t dt. Now, the way you solve these multivariable integrals is you only treat the variable that's in the differential at the end here. So in this case, dt. That's the only one you treat as a variable. Every other variable you get to treat as a constant. Um, and so we have each of these three functions here. I plotted them on the graph. So it's going to be each of these three functions multiplied by this exponential here. And that's the integral that we're taking. But it's good to familiarize yourself. This is what those functions look like without multiplying it by e to the minus st. So if we go to our first function, we have the Laplace transform of 1 is equal to 1 times e to the minus st dt integrated from 0 to infinity. And obviously, anything multiplied by 1 is itself. So it's just this integral that we're solving for. And again, we're treating s like a constant because we're integrating in terms of t. We're not integrating in terms of s, so we just treat it like a constant. And e to a function in the exponent is just the integral. That's the same thing. It's just e to that function, but divided by the derivative of the inside in terms of t. And so the derivative of the inside is negative s. And so we get 1 divided by s out front, all negative, times this function, e to the minus s times t. And so we're evaluating this function here at from 0 to infinity. And we have to note which values of s this converges for and which ones it diverges for. So if s is a positive number, then we have a negative exponent. And so when we plug in infinity for t, this is negative e to the negative infinity. And as you can see, here's e to the minus x. So if you have e to the minus x as you go out to infinity, it converges to 0. But if s is negative, that negative sign cancels out with the negative sign of s. And so that diverges to infinity when you plug in t equals infinity. So we have to make the stipulation that s has to be greater than 0. This integral only converges for s is greater than 0. And so once we've made that restriction, we can just plug the bounds of t into our function. So it's negative 1 over s out front, and then it's e to the minus infinity minus e to the 0. E to the minus infinity, we just said it goes to 0, so we plug in 0. E to the 0, everything to the 0 that is non-zero is 1, so we plug in 1 here. So 0 minus 1 is negative 1 times negative 1 over s. We get a positive 1 over s. So that's how you're going to go about all of these different integrals. Is you're going to be finding, okay, which values of s make the integral converge to finite values, and then just solve it like you would any other integral. Again, you're solving as if you were treating s like a constant. So this is the setup for the second one. You get for f of t equals e to the t. The Laplace transform is from 0 to infinity, e to the t, e to the minus st dt. And we can use properties of exponentials to combine these two exponents together. So we get one exponential of e to the t minus st, and then both terms in the exponent have a common factor of t, so we can pull that out. And so we have e to the quantity 1 minus s all multiplied by t. And remember, this 1 minus s, we're treating it like a constant when we take the integral. So this is another fairly simple integral. It's going to be a little different for figuring out which s values are going to have finite values for the integral when you solve for it. But I'll leave that to you to solve, and I'll leave the last one up to you to solve. This should give you enough information that you can start solving these problems. And if you do get stuck, just let me know in the comments, and I'll try to give you a step in the right direction. Hope this helps.